Welcome. Let's look at linear equations and systems where with two variables can solve these. So in the past, you've already done these, finding out if an ordered pair is or is not a solution, doing substitution or elimination, as well as graphing, but we're not looking at that today. And then the variations where there can be a no solution or infinitely many solutions. So those are some things to be comfortable with in the past. Let's go right to doing some application problems. What you might call word problems, but they are attempts to apply, good attempts in many ways, to apply what you know with systems of equations. So let's do that here. Here's a basic, simple one. And so the first thing we really want to do is identify variables for it and think about what this is telling us. We're selling 50 condos, or the real estate agency is. Some of them are one bedroom and some of them are two bedroom. So then there's the amounts of money that they are. So I think we have what makes sense for an X. Let's say X is one bedroom condos, and we'll have Y as two bedroom condos. So we have an easy equation right off the bat because there are 50 total. We don't know how many one bedrooms there are and how many two bedrooms there are, but we know that the total of them is equal to 50. So right there, we have our equation. The second equation will be based on the amount of money. So a one bedroom is that much, 360,000, and a two bedroom is 450. So if I sell 10 one bedrooms, I'll have $3.6 million. And if I were to sell 10 two bedrooms ones, I would have 4.5 billion. So it's the number, the X times the amount of money for each one that tells us, so this X times 360 would be a large amount of money. And this Y times that 450 is a large amount of money. And together those would add up to that. So our second equation would be the 360,000 times X plus the 450,000 times Y. And the amount of money from selling those condos and the amount of money from selling these other condos is going to equal to 21,150,000. And I can put commas to make it more sensical for most of us. Well, here we are. We have our two equations. And I think the easiest way to do this is to we have two ways to do it. We could solve this one for Y or X and then plug that into the other one. Or we can, so that would be substitution method. The elimination method, or we would do the elimination method, I'm going to take this first one and I'm going to multiply by 360,000 for each. So that one becomes 360,000 X plus 360,000 Y is equal to, 360,000 times 50 is 18 million. So what I did here is I multiplied that one by 360,000 so that I could eliminate these two X's, because now I can subtract and the X's go away. And it allows me to get 450,000 minus 360,000 is 90,000 times Y. And the 21,150 minus 18,000 is 30,150,000. There, that's pretty good there. And at this point now, it's just regular calculations. Let's divide both sides by that 90,000. And we have that Y is equal to 35. So if Y is equal to 35, then we can put that back in. We have this one. Let's put 35 into that. X plus 35 is equal to 50. Subtract 35 on both sides. And X is equal to 15. So that means we have 15 of the one bedroom condos. I think I want to write that. In fact, I'll write it with the words one bedroom condos. And we have 35 of the two bedroom condos. Now, the only truly difficult part of this actually is arriving at the equations. So that's why practicing the similar ones to this and thinking carefully about the wording of this and how I figured out x plus y and adding them up to 50 and then multiplying with the amounts of money gives us our two equations. We're going to look at three other types of applications on the next pages. Start with a mixture application. A candy company going to mix 30% fat content chocolate and with a 12% fat content chocolate to obtain 50 pounds of a 20% mixture. So we need to know how many pounds are being used of both. So let's do the same thing as the last one, where I'm going to put X's and Y's. And we have three different things. We have a 30% chocolate, a 12% chocolate, and we're trying to make a 20% chocolate. Well, let's make X equals the pounds of 30%. Now, I can keep saying fat content chocolate. I'm just going to say chocolate. And then Y is going to be the pounds of 12% chocolate. And so let's take a look at what we're going to do. Step one for this is I'm going to add those two up. The amount of pounds for X of the 30% plus the amount of pounds for the 12% is going to equal 50 pounds. So X plus Y is equal to 50. And I'll even write that. Let's write that here. It's total of 50 pounds, which comes from some 30% and some 12% chocolates. So that's how we get that one. And so the step one is to make these equations. Let's write that here. Make the equations. And I have one of them already because we're adding it up to the 150 or to the 50. The other one is going to be based upon the percent. So we have a 30% and a 12% as to make a 20%. So we can use that to our advantage by saying the 0.3x, because that's 30% of as fat content, plus 12%, which is 0.12, is equal to a 20%, 0.2, times the 50. That's our second equation. So the first equation is the total of 50 pounds, and the second equation is based on the fat content of each type of chocolate. Now we have our two equations. Okay, let's do something with them. Okay, so step two is to solve the system. And the system is two equations, and that's to find the intersection point. And the intersection will be an X and a Y, and it will be the X and Y that we need for the amounts of each type of chocolate. Okay, so we have X plus Y is equal to 50, and 0.3x plus 0.12y is equal to 0.2. Well, 0.2 times 50 is 10. So we'll leave it with a 10. Let's do this one as substitution. We could do it with elimination, and we could do it with substitution. I'm going to do it with substitution. I'm going to subtract x from both sides, so I get a 50 minus x. So I am now going to do, and with this, where I'm going to do 0.3x plus 0.12 and I'm replacing y with 50 minus x, because that's the same as y. Y is equal to that, I can replace y with it. And now it's just a matter of doing the calculations, multiplying it out. 0.3x plus 0.12 times 50 is 6, minus 0.12x is equal to 10. So I'm going to subtract 6 from both sides, and these other two things can be just put together because they're on the same side. So 0.3 minus 0.12 is going to give me 0.18x, and 10 minus 6 is 4. So let's divide by the 0.18, and x is equal to 200 over 9, which we would say is 22 and 2/9, or we could approximate it as 22, and it's actually was it 222, I believe, yep, 0.222, it would repeat, so we'll just leave it as one decimal place there. Okay. Now that's what x is. Let's do the approximation, or we can do the fraction. Now let's figure out from this what the, I have enough room here, I don't have to go down. I'll do this, where if that's what the x is, then we need to find the y. Y is equal to 50 minus x. So y is equal to 50 minus 20.2, well, that's approximate. Or I can do 50 minus 22 and 2/9. So this will give me 27.8. It's actually 27.7 repeating. Okay, 27.7 pounds of 12% fat content chocolate. And we can put it in fraction form here. Actually, I need to not, I think I'm going to do that a little differently here in just a second. Oops. So let me say it y is approximately 27.7, or I can say 27 and 7/9. We'll keep the approximation for it. So I'm going to use these approximations because we normally talk in decimals instead of fractions like that. Although in a company like this, they have to be very precise. So they probably put quite a few decimals out. So our answer is going to be here would be you need 22.2 pounds of 30% fat content chocolate, abbreviated as FC, and 27.7 or 8. I guess it wouldn't be, let's see, 0.777, so I should be rounding that to 8. Hold on. I need to make that smaller eraser. So it's really an 8 here. And that means this is 8 pounds of 12% fat content chocolate to make a 20% fat content chocolate. Box the whole thing, but I'm going to say 22 pounds of 30%, 27.8% pounds of 12%. Okay. Oh, I want to include at least the pounds in here. So this one, now I could have gotten the same answer if I decided to do elimination like I did in the problem before. However, I chose to do substitution as much to show a different way than anything else. They're both completely valid methods there. That is a mixture problem. Let's now take a look at a motion problem. A motorboat. This one's going to require a different kind of thing, a formula. In fact, we don't even need x's and y's. What we will use instead will be the distance formula. And the formula for distance is that distance equals rate times time or D equals RT. So we'll work with that in a moment. A motorboat's traveling 36 miles downstream. Okay, now I like to show like what's happening here. So it starts at a certain place and it goes 36 miles. And it's going downstream right now. And it takes 1.5 hours. Then it comes back. And it's also 36 miles that way. So the distance is the same. And this is now upstream. But this time it's going, or it's returning. Oh, wait a minute, downstream with the current. Now coming upstream, the current's slowing it down, so it's taking longer. It's hours. And from what it says, well, actually, we don't know. It's against the current, but we don't know how much the current is. But that's what we need to find. We need to find the velocity or the speed here of the current. We want the velocity of the boat in still water and then what the current is. So what that means here is that when you're going downstream, your speed is the rate of the boat plus the amount of the current. And when you're coming back, it's the rate of the boat take away the current slowing it down. So this is actually R. I put R twice so I could call it boat plus, or something like that. Boat plus current, boat plus current. So now here we need, let's take a look over here at the distance and rate times time. So distance equals rate times time. Let's talk about it for downstream. So the distance is 36 miles. The rate is the boat plus the current. And that's multiplied by the amount of time, 1.5. Now, we can do the same thing, D equals RT, and upstream. It's 36 miles, and here it's the boat minus the current times, now not 1.5, but rather 2. So let's multiply this out. I have 36 equals, multiply these in here, 1.5. Oh, wait a minute, I can do that, but let's do this the easier way. Let's not multiply that. Instead, let's divide both sides by 1.5, and we get a much easier answer. What we get, 36 divided by 1.5 is going to give me 24 and B plus C. Over here, if I divide by the 2, I get 18 equals B minus C. I have two equations. Let's put them both over here. I have two easy equations because look at this. I can simply add these two equations and I get 42 is equal to 2B. So B is equal to 21. Well, now that helps. If we know that B is 21, we can find C by taking one of these. This one. 24 is equal to 21, which is B, plus C. Subtract the 21, and C is equal to 3. So we now know our two answers. Boat's speed in still water is 24 miles per hour. Current's speed, or velocity, that's what they called it, is 3 miles per hour. There. Yeah, I might as well continue to do more of these since I'm already got so much of it done. Good. And we got that. Let's go back and review what we did here. So I did this as one to figure out in order to do these two equations. Okay, so it's like 1A and 1B. 1A and 1B. And then 2 was solving them. And then 3 was making sense of what was happening with the C. Okay, so it's really just a 3-step type of thing. And in this case, though, we had to know this formula. So remember, distance equals rate times time. The last type of equation is a break-even one. So let's go through the details of this. You invest $30,000 to start a business writing greeting cards. Your supplies cost 2 cents per card, and you're selling each card for 50 cents. Hence, X represents the number of cards you produce and sell. Okay, so what's the break-even point? So it should ask, what is the amount? How many cards would be the break-even point? So the actual break-even point, what the meaning of break-even point is the amount where costs equal the revenue. In other words, the amount that you're spending and the amount that's coming in to cover that spending, when it's equal, then you no longer are losing money. You're not yet making any, but you're not losing any. You've matched up your costs and revenue. So let's go ahead and do what they say. X is equal to the number of cards made and sold. Okay. So investment first, the costs. Your costs are equal to your investment amount of 30,000 plus all the supplies you need in order to make the cards, which is 0.02x. So we have one equation right there. Then we have another equation, revenue. The revenue, or the amount coming in, is however much you get for as many cards. So you are selling each card for 50 cents. And so that's your amount of revenue. The break-even point is when costs equal revenue. Break-even point. So, however, we know that this costs 30,000 plus 0.02x. And the revenue we know is this amount. We have an equation. All we have to do now is solve that equation. And it's the same variable. It's only one variable equation. It's in there twice, but it's only one variable. So let's subtract this 0.02x from both sides. And what we get is 30,000 is equal to 0.48x. We're going to divide by that 0.48. And we get that x is equal to 62,500. That is the number of cards we need. That's our x. Remember that x is the number of cards made or sold. We now have our number. So the break-even point is selling 62,500 cards at 50 cents each. There. Now let's think about what happened in this problem. So really all I had to do first was to identify a cost equation and a revenue equation, put them equal to each other, and then do all of the work to solve for the amount, and recognizing what the amount is. That is the break-even point. So what that it is, the cards. It's easy to think of it in terms of, oh, that's the amount of money we need, but it's not. It's the number of cards that we need, because that's what we identified at the beginning. So in this problem, you were making the two things equal to each other. In this problem, we had two equations based on the current of the boat plus or the velocity of the boat plus the current, or taking away the current, or being the amount being lowered because of the current. In the problem before that, okay, we made two equations, one based on the total number of pounds and the other one based on the fat content of the pounds, just a part of it. And in the one here, the first one, it was the matter of the two things and the amounts of money that they were worth and the total amount of money. So these are actually, this one and the second one are very similar, but exactly, because we have decimals too. So you really have four different ways to look at doing things here based upon the type of the question. So what you really want to do with any of these is read the question carefully, identify variables, and set up some types of equations that make sense based upon the situation. I hope that helps with doing these. Thank you for watching and listening.